Greetings. A warm welcome, sir. Myself, Amit Reddy, and these are our teammates. And we are hoping to give a brief methodology of our project implementation. As a part of another course project, we have developed a Flutter application and a website, which we named it as UpShot, because its main objective is to boost students' academic performance. This project includes cloud aspects such as file sharing system, code editor, and collaborative text editor. So initially, I'll try to explain about the application I have developed using Flutter architecture. The Upshot app includes features like providing previous year question papers, model papers, quizzes, creating groups, which gives access to file sharing system, chat, and to-do list, and also upload notes and get access to professor notes and books. Now, diving into apps demo. Flutter can be easily integrated with Firebase. Authentication, real-time data storage, and real-time file storage are the features provided by Firebase. After entering the user credential, we can log into homepage. This is homepage, which shows all the features mentioned. When we enter into the groups feature, we can find the features like group chatting and to-do lists. This is to-dos list. Commit is a model that is used to develop the chat and file sharing feature in the Flutter app, where commit uses long pooling with Ajax. Long pooling uses HTTP calls, allows the client to specify a longer time duration when listening for a response, which is normally avoided because the timeout period is used to indicate issues talking with the server. Profile page shows the progress getting into the backend. We have used Firebase. Here, authentication is given an unique ID. Using that unique ID, we can store and retrieve data of the respective users as shown. Now, my teammate Aman Vignesh would like to present and give a brief about text editor and their technologies.
So basically, I also built a website for the same version. It also has most of the same features, and I used HTML, CSS, JavaScript for front end and MongoDB for backend. So I'll just show the demo of the website. So this is the home login page. After you log in, this is the home page. Uh, as you can see, there are two features at the starting itself: syllabus and take a quiz. If you select a syllabus, it will show you the list of courses, and if you select a course, you will get access to its syllabus. And another key feature is quizzes. So quizzes has many features like a timer, and once you select an answer, you cannot select other answers. And it will also show you the wrong, if you select the wrong answer, it will also show you the correct answer. And as you can see, each question has a 60-second timer. It changes according to the subjects. So it will show my score. And also, you can access you to your profile, where your details like your full name, email ID, semester, degree name, your faculty advisor, his email ID, all the details are provided at one place. And also your progress in the syllabus. You can track your progress, how much syllabus you completed, and how are the scores in quizzes. So this is the main feature we considered for cloud is code editor and text editor. It comes as a part of the groups. Now you can create groups with your classmates, and you will get access to code editor and text editor. And in that, I'll be explaining about some brief technologies we used for text editor. So, collaborative text editor, what is it? It's basically like Google Docs. So, multiple users can edit and access the document at the same time. That's what basically what we did. We did not try to create an exact replica. So, the behavior and appearance of a text editor can be extracted at any point in time, like a snapshot, basically a snapshot, and it is still stored in a simple JavaScript object. Now we call this JavaScript object as document state. This document state is very important. In order to collaborate, this document state must be shared among multiple peers by sending message between them over an insecure network. Now to manage all this, we need a proper protocol. So what's the biggest challenge we faced? Conflict resolution in text editor. Well, imagine you and I type something at the same time. In such a scenario, we both will end up with a different state, and one of the two changes, either yours or mine, will be overwritten. Now, what we call, there are official names for these two issues. One is convergence, and the other is concurrency. What is convergence? All editors must converge to the same document state after a finite amount of time. What is concurrency? Edits that occur in a parallel lead to a correct end result independent of the order they are executed in. So here we show an example. For example, there's a text called how to build a text editor. Now you are accessing eighth position and I am also accessing eighth position at the same time, at the same place. So if we don't have the conflict resolution, we'll end up with a very messy line, like how to be cool ill the text editor, which is just a messy line. So what did we do? There are two technologies to solve this: OTs and CRDTs, operational transformation and conflict-free replicated data types. Now, Google Docs uses OTs, operational transformation, but we used CRDTs. Why? Now, I'll just explain what are these basically. Now, OT, operational transformation, represents the document state as a sequence of operations. So now every operation is created on a top of local snapshot. Now imagine that that operation is sent to a peer that made and edited in the meantime. That peer will have a different snapshot. So the operation first needs to be transformed before being applied. This is how OT works basically. What is CRDT? Conflict-free replicated data type. It is a bit more complicated than OT. It uses more memory and bandwidth, but in return, it guarantees eventual consistency without the need of a central server. So you could say it is more theoretically complete. And OT also has many disadvantages, as the list suggests. Now, there are few key concepts involved in CRDTs, which makes the collaboration possible. The first thing is commutative plus idempotent gives us synchronization. So, what is commutative? Now, two operations can be done in very different order, but the output should be the same for all the users after a finite amount of time. That is called as commutative. Idempotent. Multiple changes on the same object is registered as a single change. For example, you and I delete the same word at the same time. The database will see it as one deletion, not two deletions. So that's idempotent. If we both mix these features, we'll get synchronization. The second thing is making all operations unique. So every single addition, every integration, every modification you do, it will be given an unique ID so that the database can clearly bifurcate between the changes, and the changes will be reflected without any hassle. The third one is order of alphabets. Now the order of multiple characters, multiple alphabets in the text is the same in which the IDs come. So the final most thing is fractional indexing and globally unique fractions. What are these? Let's assume there are two unique IDs, and you want to there are two different characters, and you want to insert a character in between that. So as we said, in the order of alphabets, the IDs will be sequential. Now, how can you insert in between that? So there we introduce the concept called as fractional indexing. What it does is you create a fractional ID whose value is between the IDs of previous and later characters. Now, globally unique fractions are used to create these unique IDs. So this is how we try to resolve the conflicts that occurred in our text editor. Now, the demo of text editor will be shown my teammate Gagan.
So we built a real-time collaborative text editor based on CRDT. We created this by using several technologies such as React, MongoDB, Socket.io, React Router, and many more. So with React and Quill, React is used to create the user interface, while Quill is a fully featured and open source editor. In Quill, there is a concept called deltas. Delta says to insert each character. With the use of this, two users can modify the same document. Also, we used Socket.io and MongoDB. The communication between multiple clients and the server is provided by Socket.io, and the changes made to the document are permanently stored in the database using MongoDB. So we deployed our text editor in Heroku. Now I'll show our text editor. So this is our text editor. In this, we can change the style of the text by we can make it bold, italicized, underlined. We can insert pictures. We can change the color, font, and we can change the font style and many more. At the top, you can see that there is a document and then there is a unique document ID for each document. We used an editor called Quill, which is a fully featured and open source editor, and integrated it with CRDTs as Aman already explained. This is the main reason why we chose Quill. It has the concept called delta. Deltas are operations that can be performed to get from one step to another. Delta is based on the concept of CRDTs. So, so if I type some text like this, what Quill does is it inserts each character. First it inserts C, then L, and so on. So so if I create another instance, we will get a document with different document ID. So the changes present in one document are not reflected in another. So we can observe that we get different IDs for different instances, which we integrated with groups feature in the website. So in order to communicate back and forth, we used Socket.io as which is a standard library for WebSocket integrations, which will make it really easy to do real-time connections between the client and the server. So our client is running at port 3000 while the server is running at port 3001. So we used course, which is cross origin request support, that allows to make requests from two different URLs. We can also make connections between two different clients and a server easily using Socket.io. If we have documents with same IDs, like I'm copying this URL. So these are documents with same IDs. So if I type some text here and some text there, both the changes are reflected in both the documents. So if we have documents with same document ID, then multiple users can change it easily at real time. So teammates from same group can change the document at a time. Now Shubham will explain about the code editor.
Our project includes an online code editor. Now let's see what's in our code editor. I'll start from the features. All the members of our team will have access to this code editor and be able to work together on any project which requires code compiler. This code editor offers four different programming languages that are Python, C++, Java, and JavaScript, which with easy user interface, which is similar to most of the online code editors which are widely used and loved by people. Now, I'll discuss the technologies used in making of this code editor. The front end is completely developed using HTML, CSS, and vanilla JavaScript. For the compiling purpose, we have used an embedded CDN, that is the Monaco editor. Monaco editor is Microsoft's open source code editor which powers Virtual Studio Code and is packaged on npm, which is transpiled and published on JavaScript. So all the basic features which is present in VS Code, like prettier formatter and auto completion, which makes it a favorite for many developers, are also present in our code editor. For the backend part, we've used MongoDB, which is a cloud native document database. Now I'll show you the demo of our code editor. As you can see, there is four programming languages, as I've already mentioned, like C++, Java, JavaScript, and Python. Okay, I'll show you a demo example of any particular code. So this is Python, and I'm writing print hello world. So let's see what happens. Okay, as you can see, it's giving the correct output, even in the case of JavaScript. We also have the option to insert template for current languages. We can add new files and many things. It's loading. Okay, even in JavaScript, even in Java, the output is correct. Hello world. Okay, so coming to our next part, now Amarnath will cover the most important part, that is the deployment.
We deployed our website in AWS using an EC2 instance, and real-time collaborative text editor and a code editor are deployed in Heroku using Heroku CLI and linked to the website. Now I will show how we created and launched our website in using EC2 instance in Amazon AWS. Now it's shown in the AWS management console. We need to select an EC2 instance. An EC2 instance is an elastic compute cloud is one of the most popular service of AWS. EC2 lets us rent virtual servers or computers where we can host our application or data. First of all, we need to go to instances. It shows the instances which were we created. For a demo purpose, I will show how to create an instance. First of all, we need to go to launch instance. Next we need to select which type of AMI we need to go. For our purpose, we have chosen. అరే ఇంటర్ఫేస్ మారిపోయింది కొట్టంది ఏం చేద్దాం ఎడిట్ చేసుకున్నా స్టార్టింగ్ చెప్పనా
ఇక్కడ నుంచి
ఓకే నెక్స్ట్ choose an next we need to choose an AMI for our deployment purpose. For our project, we have chosen Windows Microsoft Windows Server 2019 base. After which we need to choose an instance type, which already provided by AWS, free tier eligible. Next, we need to configure instance details like number of instances we required and number of hits it will have. Next, we need to add our storage. It automatically adds our storage of, it will use a capability of 30 GB. Next, we need to add tags. Tags are optional for our instances, so we did not use tags. After which we need to create a security group which provides the security necessary. After which we need to click on launch, for which we need to use an existing key pair. We can create a new pair, or we can use an which one already created. For now I am using the key which is already existed, which is of which is named as cloud computing. After we need to launch, we need to click on launch the instance. It takes some time to launch the instance. The instance was launched. We can get it in the control panel. Here we can see that the instance was in pending state. After a few minutes, it will be launched, and we can use it to deploy our web pages, etc. For example, we already deployed our website in AWS, and the IP address was provided here, and we can also get DNS IP address too. And we click this, it will take directly to our website, which was already explained in detail by one of my teammate, Aman Vignesh. Now I will explain how to deploy deploy our application in Heroku. We tried to deploy the text editor in Heroku using Heroku CLI, which is nothing but command line interface. Initially, we encountered many errors, versions by versions. We tried to resolve all the errors. In fact, one of the key reasons we used Heroku, it has one of the best version control system. To be precise, it took us 52 deploys to resolve all the errors and make it completely functional. By default, Heroku runs our Node.js application on some randomly available port which is stored in the process.env.port variable. So we need to make sure when we start the server, we are using the environment variable. We have already added the code for it in our server.js file, which says take the port value from the source process.env.port in enrollment variable. And if the enrollment variable with the name port does not exist, then use default value. Then we are starting our server by accessing the variable port.
Thank you, sir. This was all about our presentation, the methodology and the deployment part. I hope we made it clear. And it was very great to do this project. And you gave us many valuable suggestions and to explore this opportunity, how we can apply this in cloud. So we'll be grateful for that. And thank you very much again.